Well, thank you so many people for showing up on your lunch hour and for the last day. It looks like there's still a lot of people here today on the last day, so people aren't taking off. I think that's a good sign. So hopefully everybody's gotten value out of the conference, and feel like you saw some good stuff. All right, I've got 12 o'clock, so we. We haven't closed the door yet, so I guess we're still waiting. Are we ready to go? Not yet. I'm going to wait till I have the go ahead. We still got people coming in, so I guess we're not starting just quite yet. So for the audience, how many people are from California? Okay, a lot of people from California. How many people from outside of the U.S.? Wow. More people from outside of the U.S. than inside the U.S. How about East Coast? Pretty good East Coast. Middle America. Okay. Who'd have been the farthest? Anybody from Asia? Anybody come all the way from Asia? Yeah, very cool. All right, so you got the longest travel. Excellent. So another interesting talk I saw around microservices, a guy, a DBA from CERN, gave a talk on data in microservices. And he gave it from the DBA's angle, which isn't normally the angle I think of, right? Because my background's development. We always think about data in microservices from a developer's perspective. You manage your own data, and how do you synchronize? How do you keep things together and consistent? And he came at it from the other angle that you actually put more stress on your database. The more you pull out of your database, the worse the performance of your database becomes, which is almost counterintuitive, but it kind of made sense when he talked about, if you want the best performance out of an Oracle database, what do? You write like PL SQL, right? And stored procedures and materialized views and stuff, right? Well, that's not at all what you do in a microservices architecture, right? And you pull everything out, and he showed us really great examples. He had code examples of this, that paradoxically this puts more stress on your database because it does more cycles translating things back and forth, right? So a whole other thing to worry about that I never worried about before. But I thought it was really, really interesting take. So guys, is it not 12 o'clock yet? I've got 12:04 on my. Are we recording? Oh, all right. All right, thank you for joining the talk. I didn't know we were live yet, so the first couple minutes of video will be really boring if you're watching at home. So we're going to talk about reactive programming today, reactive microservices, and reactive systems. So throw out questions if you have questions. There are prizes for questions, including some early access copies of this book. If you want to order it yourself too, it's 50% off with that code. These slides will be available to you afterwards. Written by one of my colleagues who's on the VERT.X project. A little background about me. I'm a solutions architect at Red Hat. I've been at Red Hat for almost 10 years now. I'm a service community of practice. Used to be a rules and workflow SME. I got my start in the .com days hacking JavaScript, and I've been paid to write all these languages, which are in alphabetical order, not the amount of work I've done in them, because most of my career has been Java. Also done a bunch of Ruby, but I've never made a dime off of Ruby, right? But I did write a bunch of Ruby, at least for some point in time. So you're all here, so this matters for some reason. Hopefully this matters for the same reasons that I think it does. And I'll tell you the reasons that I think reactive matters. Starts with this guy, Jakob Nielsen. Has anybody heard of Jakob Nielsen? Anybody know who he is? There you go, one person, right? So I mentioned I started as a .com web guy, and in the .com era, this guy was a guru, which is kind of amusing because he had a really bland website, right? But he's a user experience guy, and he's been doing this for 46 years. He started off doing user experience on green screen mainframe terminals, right? Which there was such a thing as user experience for green screen terminals. And then he moved into, fat client desktop applications, and now into web and mobile applications. And in all of these years, he has these three numbers that haven't changed: 0.1, 1, and 10. And 0.1 is 0.1 seconds, and that's the amount of time that an application can take before it gives you feedback so that you feel that it's engaged and responsive. And that's why you see, the spinning beach ball of death on a Mac, or why you see spinners on websites and page loading, right? Because the system wants to tell you, hey, we're still responding, we've got your request. 1 second is how long you go before you mentally begin to context switch. So if you click something and you don't get feedback for a second, you begin to think about that email that you had to write, or did I make the appropriate changes to my fantasy team, right? And you begin to context switch. At 10 seconds, you actually context switch and go do something else, right? So if you click something and in 10 seconds you don't get feedback, you're done. Well, reactive systems are all about moving fast. So the other reason this matters is Netflix, right? So, and Ben Christensen is a guy I'll talk about, and I have some links to some talks he's given on YouTube. He's really, he was one of the implementers of RX Java, and he talks really, really well about this topic. So when Netflix first came out, they would build this page that you get, when you log into Netflix. And at one point in time, they ended up with something like 30 different web calls to build this page, right? So they make 30 different REST calls to build your homepage. And that's obviously not very performant, certainly not in the 0.1, 1, and 10 paradigm, right? And it would take a long time to build this page up. And so they went back to the drawing board to find out ways they could make this load faster. And they came up with RX Java. I'll also tell you amusingly, one of the things that you'll see in reactive programming is the notion of failing becomes like a first-class concern, and it's okay to fail. We can handle failure, right? We understand that failures are going to happen, and we handle them very quickly. One of the things that they'll talk about Netflix, they can't return something, they have defaults. And I like to think this top picks for dad, this is obviously my Netflix login, right? So this stuff is not top picks for dad. So I think that, because dad being my account, either they failed, this call didn't come in and they used some cache, or maybe my kids had just logged in under my account and were watching, chasing monsters in the swamps, right? Either one of those two. I like to think that maybe their call failed and they handled that in a reactive manner, right? But reactive is responsive, and that's why this topic matters, right? There are also tools. We were talking about tools a minute ago. I'm not going to look at all. We'll look at 4 of these tools today. So akka is one of the big tools, and if you guys have followed Lightbend at all, they've talked about this a lot. They authored the Reactive Manifesto, which we'll see. VERT.X is a Red Hat supported project. RX Java, Spring Reactor, and then Node.js was one of the instrumental tools that kicked this off, right? The Node.js server. And we're going to talk a little bit about the difference between reactive systems and reactive programming, because they are a little bit different. Systems, obviously, we're talking about building big systems. Programming, we're talking about programming very specific tasks. And we're going to talk about both of those. So reactive programming looks a lot like this, at least in the RX Java world, it looks a lot like that. And then reactive systems are all about being responsive. And we'll jump into all four of those. So traditional programming or imperative programming, right, the way that we typically write code when we begin writing code follows these steps, right? We call a method, we store the result in a variable, and then we do something useful with that variable, right? So in an example, we have a method, an infinitely useful method called compute, right? We take in two ints, we get back another, we add them together and get them back. So we have this code that does something useful, system out print line. And yeah, I know we should be logging, but come on, we all use system out print line. It's actually pretty useful thing there. So we call our method, we store it in our variable, and then we do something useful with that variable, right? We call compute, we get our response, and then we print out our response. That's traditional programming. So in asynchronous or reactive, we do this a little bit differently, right? So first we create a method that does something useful, like our system out print line method, right? We're going to do something useful there. Then we define an asynchronous call that calls that method and passes in something to do. And then we just kind of do other stuff until it comes back. And so the way that looks is we would have a method like our compute, and this is a VERT.X kind of paradigm, but in our compute world, we take in our values and we take in a block of code, right? And we have an interface here so that we know that we can just call handle, like do something, execute this code, right? If you use JavaScript dynamic languages, this kind of notion has been around a long time. And with Java 8, we have lambdas. We can do this very easily. And so instead, we have this method down here, compute, right? Compute takes our two numbers, and we pass in this lambda that says system out print line. But we're just going to kind of do stuff in our program until this comes back. And when it comes back, then it will print out this line, right? We're not waiting. We're not blocking for that to happen. One of the negative things, though, about programming with callbacks, right, is you can kind of end up in callback hell, right? So we get our callback here, other stuff, and then we get, we do some if-else's, we get another callback in here, we have some other callbacks in here, and you can end up with these big nested callbacks that get pretty tough to navigate, right? I mentioned I started out my career doing JavaScript, right? Especially in the early days of JavaScript before we got good at packages and things like that, right? This is what all our code looked like. At least my code looked like that. My code, my colleagues' code looked like that a lot, right? All right, I also mentioned we're going to do 4 demos here, so let's talk about some of the solutions by looking at some code first. So the first thing we'll start with will be RX Java. And I've got to give a shout out to this guy, Victor Grassi, who I don't know this guy. I read his description, this blog post, and then lost it. I didn't find it again for ages. So I implemented his examples, but this was his idea. And I finally found him again. I remember he was on InfoQ. I thought it was on the wrong site. So what we're going to do here in this example, if you haven't seen RX Java or Reactive Extensions before, this will be a quick introduction. We have something called an observable, and in the Reactive Extensions world, observables are everything. And there's subclasses of observable. But the key is we have an observable, and then we subscribe to that observable. Can everybody see these? Is text okay? You guys in the back, text okay? Good, okay. So what we're going to take here is I've got an array list of words, and I'm going to say observable just. This is the other piece. We have observables, and then we have operators. And there's a lot of operators that give you a lot of power really quickly and concisely. So let's run this code. And what we got here is not really all that interesting, right? It just spit out just the words, right? So let's take a look at a different operator. And this time, instead of just, we're going to say from iterable. And as you might guess, it's now going to iterate over these words, right? So we got one per line, right? Because we grabbed one word at a time. So now we're going to do something. This example is going to look really silly at the moment. We're going to call a range starting with 1 and going to 5, and we're just going to spit the number out. So that's not really all that interesting, right? We spit out 1 through 5. And that's not interesting, but now we start to see something interesting, right? So now we're going to start to combine these operators. So we're going to take our from iterable with our, which is going to grab one word at a time, and we're going to zip with our range. And we're going to give it an infinite range, which is OK because we only have a set number of words, right? So we're going to start our range at 1, and we're just going to go forever. And then we're going to subscribe on it. And nothing happens in this world until we subscribe. So now what do we get? This gets a little more interesting, right? Because that's not a lot of code that we wrote to do that. And start doing a little more interesting things in here. We can split every letter. And this is, remember that when you start typing, right, they say the quick brown fox jumped over the lazy dog, right? That gives you every letter in the alphabet. So now we've got 36 letters here. So we have 36 unique letters. We're still only really writing a couple lines of code here. Now we'll add in another one called distinct. We run that. Filtered out. We no longer have 36 letters. We have 25 letters. Right? And we're supposed to have 26 letters, right? Because there's 26 letters in our alphabet. So finally, we'll add something else in here, sorted. So now, we have them sorted in order. And we can go down and see what it is we're missing, right? So we're missing our S, right? So really quick, we took, and this isn't much code, right? And if we think about the way we would have done this in traditional paradigm, if we were going to loop over everything inside of this array and then run these calculations on it, store it in another array, and then sort that with a comparator, that would be a lot. As we grab this from flat map, right? This flat map phrase for me was very confusing when I started using it. But what it's doing, taking two different things, them, and then we're running distinct on it. We're zipping with it with range in here with another observable, and then we're calling subscribe. The interesting thing about subscribe is our code's not going to actually do anything until something happens with the subscribe, right? So we've got a lot of power here and a lot of concision. We've done a decent amount of sorting with not a lot of code. And I'm actually running out of power. Whoops, that's not good. Instead of talking, I guess I should have been plugging my laptop in earlier. So now I'm not going to give out a prize for asking why I didn't plug my laptop in before the session started, right? So the reactive extension, one of the other really nice things, reactive extensions here, you can see like this choose your platform. There's a lot of different languages here. In fact, there's just about any kind of language you could want, right, has an implementation of RX. And one really nice thing, in fact, I saw a presentation the other day of a woman, I think she was from one of the banks, and talked about how they use reactive on the front end with their Angular website, and then combine that with Spring WebFlux, so they have reactive on the back. The Spring syntax is a little bit different, but it's still pretty close. But you can see a lot of different languages, and especially the docs, especially for open source community projects, are really pretty nice. And they have these marbles. You can come drill down into these pieces. And where's the operators? In the operators, if you want to see any of these operators, you can really drill into what they do. So we mentioned like flat map, for instance, is one that you'll see a lot. When you look at this, it uses these so-called these RX marbles. It shows you, I'm getting in both of these things together, and it shows you how they pull these together. And it gives you through, it shows you which implementations are there. So there's a lot of nice documentation, which helps a lot when you're beginning to learn a new topic, right? There's also, yeah, question.
Is it like an extension to the basic stream functionality that we have in the right?
You can combine it with streams. You would really just use this instead of using Java streams.
Instead?
Yep, instead. Yep. Good question. You want a T-shirt, a book, or a Meep? One of these, or you want the early access? All right, come see me afterwards. All right. Now, these marbles, right? There's also a site called rxmarbles.com, and this guy has built all of these out in JavaScript, which is pretty cool because you can come in here and literally play with marbles, right? So you can look at these all the various operators. Like, let's go drag them around and see what's going to happen at the bottom. And you notice, like, not everything, right? So, like, this doesn't appear to be doing anything, right? But that changes our multipliers down here. And this is a really kind of fun site to get started with. And in fact, first, when you start looking at some of these don't make a lot of sense until you kind of run into dealing with streams of data and dealing with the problems that arise when you start programming in this paradigm. And then you can kind of come here and play with this, and it'll start to make a little more sense. At least I thought it made a little more sense. All right, so Reactive Extensions were started by this guy, Eric Meyer, who I think is always in a tie-dye shirt whenever I see him. He was a guy at Microsoft. I don't remember exactly what he had worked on, but he invented Reactive Extensions in his spare time. So it came out of the Microsoft world. The RX Java implementation was pretty early on by the guys at Netflix. They're a little bit different than traditional asynchronous stuff, right? And we saw that in our method. So we talked about, imperative programming, we define our method, we get a variable and then do something useful with that. In our asynchronous model, we create a method that does something useful, we define an asynchronous call for that method, and then we do other stuff until it returns. Well, in the RX world, we create a method that does something useful with the return values of an asynchronous call. So the first thing we do is we create that final piece. Then we define the asynchronous call, and that's our observable, or subclass of observable, right? There's subclasses of that. Then we attach an observer to the observable, which is our subscribe method, right? And then we just do other stuff until the events come back. And that'll make a little more sense when we look at like Spring Web Flux or VERT.X, right? Because we can do other things until our call finishes. In fact, like in the VERT.X world, one thing you do, in VERT.X world, you write verticals. And verticals like handle web requests or they talk to databases. Well, when you spin those up, you can spin those up in separate threads, and you just kind of hang out until they're all back. But you can do other processing in the meantime. So RX observables, when we looked at some of these, right? So we have observable, we can take a range as a method. We're going to go from 1 to 100. Then we're going to group by, and we're going to group by this closure. And then we're going to take that, and we're going to map those return values, basically just pipe into the next return value, and then eventually pipe into for each. Right? So you can do a lot of work with a lot of concision inside of RX. If you remember the gang of 4 pattern, I have the title solution architect. I'm an architect in my title, right? I have a title architect, so I've got to have a pattern in the talk, right? It's like a rule. Like I think you lose the title, you don't have one pattern, right? So if you remember the observer pattern from the gang of 4, it is kind of like that, right? And then brings us back to the Netflix guys, right? And one thing they talked about when I first began exploring this, I watched a number of Ben Christensen's talks. He also has the book the RX Java O'Reilly book, which I highly recommend. And he talks about how they ran into this problem because they were making, 3 dozen blocking calls. There's no way you're going to make 3 dozen blocking calls, waiting one after the other, and get back in any kind of reasonable amount of time. And if one of them hangs, it kills everything else. And so RX Java gives us the ability to spin all of these up asynchronously. And then if one of them fails, it's okay because we can just deal with that, right? And we can write that with a lot of concision and get back all those other dozens of calls. And that's how they built the Netflix API, or UI. The operators, right? Lots of different operators. Zip and zip with are the things you'll kind of see the most of. All right, so to sum up reactive programming at its most basic level, or at least in the ReactiveX world, we have observables, we have operators, we have marble diagrams. There is a bit of a learning curve. I mean, that code looks kind of strange, right? So the code looks, if you haven't used it before, it looks a little weird, right? Come on. It looks a little weird, right? Unless you guys are all smarter than me, right? It looked weird to me when I started, right? So it was a little weird. All right, so now we'll jump into, but the learning curve is not really that big. Once you kind of go through stuff, it's not as hard once you begin playing with it. All right, reactive systems. So we'll jump from programming all on to building really large systems. This is the Reactive Manifesto. You guys remember the Agile Manifesto? Well, we have a Reactive Manifesto. We need a manifesto for a paradigm shift, right? This was started by the guys at Lightbend. Has anybody here signed the Reactive Manifesto? All right, I signed the Reactive Manifesto. Excellent, we have another signatory back here. So after this talk, everybody's going to join the two of us. Come on, brother. We'll join the two of us and sign the Reactive Manifesto, right? So the Reactive Manifesto is about building big applications. And it started from the consultants who work at akka building banking systems in Europe. And they said, the number one thing here is responsive. And it's not a mistake that all of these arrows point up to responsive, right? So all of this feeds into building responsive applications. So this is the real key, right? And this goes back to the guy that I started with, Jakob Nielsen, right? People get bored, right? They want feedback really quickly. And this is all about giving people feedback really, really quickly. So the first piece of this, right, sort of first piece of building really responsive reactive systems is that they need to be resilient, right? And they can't go out, right? They can't die. And then that brings with it a number of other requirements, right? So they need to be self-healing, right? So that's going to also have other implications into, say, how we maintain state in our application, right? So if my component dies, how do I bring another one on and, continue processing? If something fails, how do I make sure that doesn't bring down my entire system, right? So we've talked about if we're making a whole bunch of blocking calls, if one of those calls fails, it's going to kill everything after it, right? We don't want that to happen inside of a reactive application. So another requirement, or part of the way we deliver that, right, is it has to be elastic. We have to be able to scale up. So if we get more load, we have to be able to scale up. But in addition to being able to scale up, we also have to be able to scale down, right? And of course, this obviously brings us to the fascination with the cloud that we have, right? We heard a lot of cloud stuff this week. But this gets back also into designing our systems. We have to be able to replicate, maybe be able to shard, our data or shard other pieces of the system. We can't have bottlenecks. And we also need to be able to get feedback, right, around our system so we know when we scale up and when we can scale down, when it's safe to do that. The other big piece here is that it needs to be message-driven, right? And this comes across not just in the reactive world, but a lot of times when you start seeing, especially in the microservices world, in distributed systems in general, right? But the notion is we're going to use messages to pass things back and forth. We're not going to go through like the traditional way of doing, say, transactions, right? We're going to pass messages. We're going to build our applications to do things like eventual consistency. We'll see this especially inside of akka and VERT.X. So in the microservices part of this, I think it's a natural fit, or the reactive systems are a natural fit for microservices because we're blowing our systems up into lots and lots of different pieces. And we don't know if those other pieces are going to be around. They could be in the middle of a deployment. And the notion of building things in an MSA sort of forces us into this model of not knowing whether we're going to be able to make a successful call. We're also going to be making a lot more calls, right? Whereas if you have one monolithic system, you're doing everything right there in the JVM, in memory in one machine. Now all of a sudden we're not doing that, right? We're making lots of different network calls, and any of those can fail. And that brings us to our other part. So toolkits and libraries, right? There's a lot of toolkits and libraries now around reactive stuff. The three I'm going to look at today, and obviously, like if you've done JavaScript, there's a lot of stuff in JavaScript that's reactive. I'm not really going to look at that. Node.js is very much reactive by nature. I'm going to focus on Java stuff. So I'm going to talk about akka, VERT.X, and Spring Reactor or Spring Web Flux. And I put them in this order because they are kind of Venn diagrammy, I think, in that akka is very opinionated about how you do things, and it is reactive through and through, right? It was built as a reactive framework, and that's what it does. VERT.X is also through and through reactive. It's reactive from the ground up, but it's also a little bit more like traditional kind of programming. And then Spring Web Flux, they've kind of hidden a lot of the reactive stuff. Some of it gets exposed, but their idea was they're going to take the reactive piece and just kind of put it into what they already have, right? And so you won't deal with as much of the paradigm. So to start with akka, I'll give you a brief aside about akka. When I first saw akka, I was attending a conference, and I sat in a room watching a presentation on akka, and my impression was, this thing looks terrible. I would never want to use that. So as I began preparing for this talk, I said, well, okay, I'm going to have to check out Akka, right? They're a big player in the system. So I downloaded Akka, started going through their docs and their examples, and I was completely wrong. So Akka is pretty cool, right? And as I began using this, I thought, you know what? I could actually see myself building an application this way and being pretty happy about it. So the moral of that story is, even if the guy on stage or the woman on stage doesn't, make something look appealing, go get your hands dirty anyway. Get hands on keyboard time with this stuff, because maybe it's just the way I'm presenting it that might make it interesting or not interesting. So Akka is based on the actor model, and Akka has actors, and actors spin up other actors, and there is a tree structure of actors, and actors communicate with one another by sending messages to mailboxes. Again, message driven, and if I didn't mention this, I should mention, these are the guys that created the Reactive Manifesto, right? So these are the guys that believe in the Reactive Manifesto. But you spin up your actors, and your actors will send messages to other actors inside their mailbox. And then based on that message content, that actor will do some work. Under the covers, it gives these guys URLs, or URIs, I guess, that you don't interact with, but behind the scenes, it maintains these URIs. And then that way, because the URI is a layer of abstraction, right? So that's how I can sort of scale up these actors if need be, right? So it can spin up more, shrink the number of actors. So let's look a little bit at what some code looks like in this world. And there's a number of, this is what our actor looks like. We have a little greeter here, so it's a little hello world message. But this greeter, extends an abstract actor. Can you guys see this font okay in the back? And it has an internal class called who2greet, right? This notion of getting, our message comes in, right? We have a message that comes in. And we use a type of class to determine what we actually do. And this, like I mentioned, you said you're using Scala with some Akka. I don't know Scala. I have some friends who know Scala, and they tell me this is a very Scala way of doing things, like using the type system to determine what you're doing is a very Scala way of thinking. Is that right? Okay, so yeah, you take a class and you make a reference. We're using, like right here, we're basically doing a switch block. Like in most world, we'd use a switch. We'd use like a number or a string, right? My other talk, I used VERT.X. We used a string on a switch. But what we're doing is we match this class, right? So if it's a who2greet class, then we put message plus who2greet, right? Hello name. If it's actually the greeting, then it's the new message. So this is one of the conventions they use. And these actors will spin each other up. So it's also got a test. It comes with its own kind of test framework built around JUnit, right? So it's pretty easy to do. Let's run this test real quick. Let's debug this test. Stop a breakpoint here. All right, so we stop on our message, and I can't zoom. All right, I can't zoom on that, but let's see if I can copy it. Sorry? Enter presentation mode, all right. But I don't want that window. That's not the window I wanted. I wanted this window. So let's copy that. So what you can see there is the URI. So it's got a URI pointing to these various actors built under the system, right? That's one of the things that Akka does in its system. So we can see what's bouncing around there. It maintains this graph system of all of these actors sending messages to one another. Let's fire through. We should get green. Yeah?
Does it make sense to use akka inside the application or regular screen?
It would be a totally different world. Yep. And Akka has So this is pretty basic. They also have modules for things like, a web module for building web apps and stuff. But yeah, different world than you would find in a Java EE. Because the question was, would it make sense to use it inside of a Spring or a Java EE world? And so the answer is no. It's its own thing. They even have their own conference going on this week. Unfortunately, so those guys aren't here this week. So that's your very quick introduction to Akka there. So to sum up, Akka, right? So Akka is all based around the actor model, right? And this is a pattern that's been around for a long time. Messaging is at the core of the system, so all of your objects or all of your actors will send messages to one another. You use the class structure, right? So you use the class structure to determine what those messages are going to do. And then it has modules to deal with like streams and web and other functionality, right? So you just you bolt those on and you can build your applications. It is reactive end to end. It's by the guys that literally wrote the Reactive Manifesto. So you're going to build a completely reactive system. All right, Eclipse VERT.X. So this is a Red Hat one. Obviously, this is the one that I have used the most and know the best. VERT.X's tagline is a toolkit for reactive applications. So it's very small, modular core that you also just bring in other modules for, like for doing web stuff or doing authentication or other types of functionality, talking to a database. And VERT.X runs similarly to Node.js, right? So we've all heard of Node.js came out. It uses a non-blocking I/O event loop, right? And so in a VERT.X world, if we get an HTTP request in, we have an event loop that's going to grab that request and it's going to push the work off into a different thread, and then when that finishes executing, it'll send the callback back to the event loop, and then we'll return something to the caller. Cardinal rule of that is don't block the event loop, so don't do blocking work. The implications of that are things like most databases, for instance, do not have asynchronous drivers, right? So Mongo does. We have an asynchronous Mongo driver. Postgres has an asynchronous driver. So VERT.X has database drivers, like for a JDBC driver that kind of mimics that, but it isn't truly, JDBC is still blocking, right? Traditional Java like persistence frameworks, JPA or Hibernate is blocking. In a VERT.X world, you would push that off into what we call a worker vertical, which is going to execute in a blocking thread in its own thread. So that way we can continue our processing. Node.js was the inspiration for VERT.X. So Node.js came out right after the guys that started VERT.X had written JBoss's old JMS engine, HornetQ. And HornetQ used this project called Netty. Has anybody heard of Netty before? A lot of people have heard of Netty. Yeah, so Netty was started by some JBoss guys in 2004. The two guys that started it, one guy's at Twitter now, one guy is at Apple. It powers most of the stuff like your updates or your iTunes store runs over Netty. A lot of Twitter runs over Netty. It also underpins most of the Java reactive stuff. So VERT.X, Spring Web Flux. Under the covers, a lot of that is calling Netty. But Netty's also kind of hard to use. It's a pretty low-level toolkit. But the idea was to take the NIO functionality that Netty provided and then combine that with server stuff to build VERT.X. And I mentioned it came from the guys that had written the JMS broker that came out in HornetQ that came out as part of JBoss 5. And so probably unsurprisingly for guys that write message brokers, an event bus or messaging is a really core piece of how VERT.X works. And I mentioned your verticals do all your work. And you can have, say, an HTTP server vertical and a database client vertical, and the way they talk to each other is by sending messages, right? So they send a message over the event bus, and this is not a big heavyweight event bus, right? There's no persistence. You're not storing this stuff to disk or to a database. You're just sending this message inside the application, and then you're going to grab it, work on it on another thread, and then send the response back, right? Also comes into the Reactive Manifesto piece of message passing, right? So we pass messages, and in VERT.X, a good practice here is to use JSON, right? So we have a JSON. We're not passing objects over the wire, right? Which gets back to our notion of, if one thing disappears, how do we send something else? We send another message, right? We're not worried about, objects disappearing. Yeah, you had a question? So the question was lower level transport. You can configure it to use TCP or UDP, right? But typically, you're going to want, and I can kind of show you an example too, but you also want to be able to spin up multiple verticals, so you don't necessarily want to know, who it is you don't want to have to wire each one in. Like I said, the idea here is just it's an application way of doing things. It's not like standing up separate brokers. And then let's take a look here. Oh, I mentioned, okay, so JSON is a first-class citizen in this kind of world here. So let's take a look here. Desktop. I'm sorry? Is it first in, first out on the message? So it's not a queue, right? So we're just going to send it, the vertical is going to grab it. It's going to be running in an event loop as well, and it's going to grab it and start processing that event loop. So there's no blocking, right? So whichever one finishes first, the callback's going to throw it back. So what it looks like in our event bus world, it just looks like this. We just grab an event bus and we send a message. Here we're just sending it to a string as our address. Our message we're using is a JSON object. JSON just is a JSON representation. But it also makes it very easy to marshal POJOs back and forth to JSON. But the idea is instead of passing POJOs around or passing objects by reference around, we're using message passing with a JSON payload, which gives us a nice clean separation. And then my other. But it also builds in, that's my Spring one. It also builds in RX Java. So if you look at things we saw with RX Java, RX is a first-class citizen in a VERT.X world. So we have things here like a single, which is an observable, that's going to get one thing back, single JSON object, and we can grab that as a JSON object, and we can send that and then map it with a response. So what we're doing here is we're calling localhost and getting the response back and creating a map together. So if we want to run that, all we're doing here is we're just throwing out the time in system milliseconds, right? So nothing too interesting. If we can spin that up, and then our client here, our client here is using that zip functionality that we saw to take the system time, take two different requests to the system time, and just zip them together. So especially like in the world when we're calling lots of different endpoints, this makes it easy to do that. Sorry, my screens are on. Some of the other things you can see here that VERT.X does is a concept of a future. And this is different than a Java feature. Java features are actually blocking, right? So a VERT.X feature is not. This is a void feature. And what we do is we pass something in here. We do this work inside of here. This is going to happen in its own thread. So we're going to deploy this vertical in its own thread. And if it succeeds, we're going to tell this future succeeds. And if it fails, we're going to have this future fail. And where we would use this here is, for instance, if we're spinning up lots of different verticals, we can do a composite future, and we have an all method. And what that all method means is, whoa, it means that I need to go a lot faster. So this all method means it's going to fire these off in their own threads. It's going to get those callbacks. If all of the callbacks succeed, if they don't, we fail. So let's jump over to the Spring really quick. I'll skip my slides. And we'll take a look at how Spring does this. The Spring guys have nomenclature, so they have monos instead of singles, but it's effectively doing the same kind of thing. If you guys have everybody's used at least Spring like Web and Spring MVC at least a little bit, right? At some point in time, so this should look pretty similar, right? So we have a client, we're getting a mono of client response, whereas we used to just get a client response, like in the blocking kind of world. Now we get a mono, and we can do these same kind of functions on it, right? So some of the nomenclature changes, but we can still do these same kind of things. And then if we look inside their router, but in their handler, where they would have just returned a response in the traditional Spring MVC, now they return a mono, right? So you return that object back, and that allows you to compose your clients this way. So let's see, just run this app real quick. And run our web client. Oh, it already ran it. So there we go. our result, we just grab our single result. All right, nature time. So we jumped through those really quickly. So to sum this up, Spring stuff is pretty similar. Some of the nomenclature changes. The ideas are all pretty much the same though, right? So we take those kind of RX Java concepts and then we apply them to the work that we're doing to give us back these pieces. So these slides, which will be available after the show, I put a bunch of links in here. This is the guy Ben Christensen I mentioned who wrote RX Java with one of his colleagues at Netflix. Really great book, and he has a couple of really good presentations that you can get on YouTube. It really helped me understand RX Java a lot. So if you're interested in RX Java and haven't used it before, I highly recommend his work. The akka space, a lot of great material from akka, from one of Marcus Eisel, one of my former colleagues from Red Hat, is at Lightbend. They have this PDF book, which is pretty interesting. You can download that. You can Google it. I think I probably have a link there too. You can get that from the Lightbend guys, and these are a couple of good webinars that I enjoyed reading on it, a couple of blogs from the guy who started the framework. Spring Webflux blog, Josh Long presentation on YouTube. VERT.X stuff, we've got a couple of our own books. These are both pretty interesting books. Some other presentations that we see on YouTube. And then there's a couple of interesting tutorials too that you can walk through, especially this like introduction to VERT.X is a really nice, quick introduction to VERT.X. All right, so thank you very much for your attendance. And I've got one guy who won a book here. I still have some stuff to give away too. So come up with some questions. Yeah.